This video will present work completed by Roger Swan, the doctoral researcher at the University of Birmingham. He is researching the application of dynamic model to water treatment works. Dynamic model take into account past events when they are calculating current performance. The dynamic aspects of the models will be discussed further on in the video. Simulink has been used to build a model of a case study water treatment works. The raw water is abstracted from a river and then stored in a reservoir for around a week before being taken into the works. At this point the water is characterized by its flow rate, clarity and temperature. The water is split between two clarification processes which are responsible for most of the improvement in the clarity of the water. In the hopper-bottomed clarifiers the water is passed upwards through a blanket of sludge formed by solids that have been removed from the water. The water is strained by this blanket and the clarified water leaves at the top whilst the solids content of the blanket is controlled by dislodging the blanket to waste. The mass and height of the blanket are both aspects of the model which are modeled dynamically. Meanwhile in the dissolved air flotation clarifiers, water has air bubbled through it which becomes attached to the solids which then rise to the surface where they are removed as waste. The water from these two processes is then mixed together before going through rapid gravity sand filters. The filters improve the clarity of the water further. Solids that build up in the filters are removed by backwashing the filters approximately every day. In the filters the pressure loss due to the filtration process is filtered dynamically based on the build-up of solids. Water leaving the filters then enters a large tank where a disinfectant such as chlorine is added. The water needs to have enough contact time and disinfectant concentration to ensure sufficient disinfection but not so much that harmful concentrations of disinfection byproducts are formed. The sensitivity of the model to changing conditions is shown in the following example which highlights some interesting points. The actual works data is shown in yellow and the modeled results are shown in pink. At this point the flow has dropped significantly. This has caused the filter head loss to decrease, the height of the blanket in the hopper-bottomed clarifier to fall, the clarity of the water coming out of the filter to improve, and the disinfection ability has increased. Unfortunately so have the disinfection byproduct concentrations. Now the raw water has reduced clarity and the flow has increased. The system responds appropriately. For example, this time the hopper-bottomed clarifier blanket height increases and the clarity of its water decreases. As a final example, the temperature of the raw water has increased. This results in a decrease in head loss in the filters in the model due to reduced viscosity of the water. Comparing the predicted performance of the works against actual inline works data gave comparable error to that from manual checks of the inline sensors carried out by operators. In this video the ability of a dynamic model to replicate the performance of a case study works has been presented. This model is being used by Roger Swan to predict how the works will respond to different raw water quality using Monte Carlo analysis and how the works will respond to different works design and operational setup.